Good day and welcome to development for IBM Software Solutions. And my role in today's webinar is to talk about the recent technology breakthrough with IBM Watson and how we're applying other content analytics solutions to help solve problems in the healthcare industry. So let's start with what is enterprise content in the first place. Well, you may not know that it represents over 80% of the information being stored today in healthcare organizations. If you look at the total picture of information, less than 20% of it is actually structured in nature and can be found in rows and tables of databases. The vast majority of it is unstructured, pretty much everything that doesn't fit into a database. And like DNA, this enterprise content really holds the key to a lot of areas of business insight, agility, and performance. We're going to spend some time today exploring that. We'll start with a recent breakthrough that IBM had earlier this year around the topic of natural language, understanding natural language, which truly is the next great computing challenge. When you think that 80% in the information being stored today is unstructured, you also need to know that it's based on natural language. And by natural language we mean the way that humans communicate. We write in natural language, we talk in natural language, we tweet in natural language. It's all based on what our learned understanding is. And we'll go into this in more detail about why this is a critical capability for the future. It starts with, in a certain sense, what's going on in business today. We have all kinds of information exploding. We're expecting 44 times the amount of information growth between today and the year 2020. And all of this new information is going to be unstructured in nature. Think about the web and Facebook and Twitter and all of these, casual conversations that are going on. We need new tools to understand this information so that we can leverage it for business advantage. And when you think about it, the legacy approaches haven't exactly worked well. I know that everyone on the event today is frustrated with searching. Searching really doesn't help us find the right answers in many cases. So a new approach is needed. We need ways to leverage all of that unstructured information, and natural language processing is the key. Well, in the February timeframe, IBM did a challenge on an American game show called Jeopardy! You may not be familiar with this game show, but basically it's a game show, it's a trivia show or a quiz show, if you will, where there's 3 contestants who are competing to quickly answer questions that are read to them by a host. And we felt that this was truly a platform by which that we could demonstrate what we felt was this next grand challenge, this leveraging natural language. If a computer could compete and win on a game show against the best people who have ever played the game show, that would be truly remarkable. And in the case of Jeopardy, it is one of the most popular game shows on the air. It's been in production for well over 25 years. So our goal was not to go on the game show circuit. Our goal was to prove that natural language understanding and its ability to understand and use all of this unstructured information had truly reached its prime time. It just so happened that we chose a game show as a way to prove that, a very public demonstration of how sophisticated the technology could be. And if you think about it, language is hard. Unlike the game of chess, you may recall in the 90s, IBM built a computer that could play against Garry Kasparov and beat the chess grand champions of the day. And back in that time, it was viewed by many as impossible that a computer could beat humans at chess. But when you think about it, chess is a very structured mathematic type of game. It has rules. There are a finite number of pieces, a finite number of players, a finite number of things that you can do during the game, and a finite number of outcomes. And what it really was a challenge around figuring out all of the possible moves by all of the pieces, applying all of the rules. And eventually, this was a problem that was solved, and we proved in the 90s that in a very structured environment that you could do this. Well, the next grand challenge is around human language. It's contextual. It's implicit. We speak in slang, riddles, idioms, abbreviations, and acronyms, you name it. And all of which is based on what we know. And since we know different things and have a different contextual understanding of them, oftentimes We as humans even, have difficulty communicating with one another. Well, a computer that doesn't have any of that context historically has really struggled in these areas. If I use the word major in a sentence, many of you will think of a military context, a person's title. Some of you will think of a musical context, a type of a note, and then others of you will think of an adjective such as this is a major advantage. And all of those could be the right context for the use of the word major. It simply depends on the other information that's being used around it. So language is hard. It's very ambiguous. Chess and structured information is not ambiguous at all. It's it's very, very precise. So let's go into this a little deeper. If the world were made up of structured databases that contained every answer to every question, it'd be really easy, and we wouldn't, be tackling this challenge. If we wanted to find out where Einstein was born, as an example, it'd be very easy to query our database and know that he was born in Ulm, or that Jack Welch was the CEO of a company called GE, General Electric. However, when you're looking at these sentences that are shown on the left-hand side of the screen here, it's often very difficult to ascertain what the answer to the question might be and what is the correct answer. If you read this sentence, one day from among his views of Ulm, Otto chose a watercolor to send to Albert Einstein as a remembrance of Einstein's birthplace. Well, we can quickly pick through this and figure out that Einstein was born in Ulm, but this is very hard for a computer to do, because a computer would first have to figure out things like what does city views have to do with a birthday? What is a watercolor? What does that have to do with a birthday? And who is Otto? So, finding correct answers from unstructured information, which, again, is most of what the world is made up of, is a completely separate set of challenges, one that before has not been well tackled by computers. So for this Jeopardy game show, there were 5 areas where we really focused on exploring natural language. The first one was broad open domain. In this game show, 1 minute you're answering a question about European politics. The next minute you're answering pop culture references. So you had to have a very broad and open domain. The second one is you have to understand natural language, because not only were the questions formed in natural language, but all the answers are as well. So you had to be able to figure out all of these crazy ways that we communicate in natural language and interpret things correctly. The third and fourth points kind of go together. If you're going to answer questions, you have to be right and you have to be confident. And in some cases, that's not easy. There are so many ways to misinterpret unstructured information that, at least for computers anyway, that being able to be accurate and confident at the same time was important. And then lastly, in order to win on the game show, you had to do this in high speed. You basically had to answer questions in 3 seconds or less. So think about it. If we're a human and you look at the first question here, if you're standing, it's the direction you should look to check out the wainscoting. We as human beings know that's down, because wainscoting is at the bottom of a wall. However, if you're a computer, you have to break this question down and figure out what wainscoting is, figure out where it is. You need to basically figure out the height of human beings so that you can directionally figure out that down is the right answer, not left, not right, and not up. And this is what basically this computing system that we built and competed and won on Jeopardy was able to do. We started by looking at the best human performance on the game show, which you see at the top of the chart here, plotted by the dots. And then at the bottom in the brown line was basically where our technology was in 2007 when we accepted the challenge to compete and build out this technology so that we could ultimately compete on Jeopardy. And in order to compete effectively on this game show, you not only had to answer a lot of questions, but you had to be right a lot of the time. And as you can see from the dots, that those participants who answered a lot of questions and answered them correctly basically were the grand champions. You can see those grand champions plotted there in red. The Watson system itself basically this is the sort of the technical architecture, if you will. It takes a question, as you can see on the left, and breaks it down, understands the question, and then considers many hundreds or thousands of possible answers. It has what's called evidence scoring to score these different sources of answers where it ultimately can answer with confidence. It uses learning technology so that it learns from right and wrong answers so that it can improve over time. And basically what you see here is a highly parallel computing capability that's processing literally thousands and hundreds of thousands of language structures, potential answers, scoring them so that it can ultimately take a question and answer it with confidence. This concept of evidence profiles is critical to getting answers correct because search simply doesn't work for most applications. So let's use this as an example. This is an actual Jeopardy question. Chile shares its longest land border with this country. Well, if you go pick your favorite search engine and Google this or search it in, what you'll probably find is that you'll get a lot of answers back on Bolivia. And you can see that by the bar in the middle that says popularity. However, being popular isn't the same thing as being right because Bolivia doesn't share the longest land border with Chile. Argentina does. And what you need to do is look at other ways of scoring the possible answers before you can make a recommendation that in this case Argentina is the correct answer as opposed to Bolivia. The reason that Bolivia shows up as much as it does is that there is a border dispute between the two countries that has been written about and is you know, a lot of information's on the web. So just because it's been written about a lot doesn't mean it's the answer to the question. Now, when you take this Watson capability and start applying it to the real world, because obviously we didn't build this to go on the game show circuit, but these concept of evidence profiles can be adapted to new domains. IBM has certainly announced press releases and you know made it not a secret that healthcare is an area where we feel this technology offers major advantages. And taking that evidence profile concept and applying it to different sources of information to help, in this example, assist in a diagnosis determination where you can look at symptoms, family history, personal history, medications, findings, and other sources of information and score those based on a particular situation, we can help physicians with more information to make optimized decisions. So with that, I'm going to flip over here rather and show you a short video on how we believe this can help in the area of healthcare.
Now we come to Watson, who is Brand's broker and the wager. Hello, 17,973, 41,413, and a 2.
Diagnostic error often results from not considering all the possibilities. In medicine, we're only as good as what we know, and we have all these questions that we need to have answered in order to carry out our mission. So imagine a physician asking a question in natural language and having Watson return the answer within a short period of time. Not only will that provide the valuable information that the physician wanted, but it will probably prompt the physician to ask more questions to get a further in-depth understanding of the whole situation. In my mind, this is the Holy Grail. We've been waiting our whole lives for this, and Watson is about to deliver. To practice medicine at the highest level, we need to know what is known today, and that's not possible for us. We need Watson.
This is a new way of thinking about how to use natural language processing, statistics, machine learning, and data mining to help people make decisions better, faster, with more access to the critical information they need.
Imagine a young woman coming to her primary care provider with an acutely painful right eye. During the interview, she complains of various symptoms, including light sensitivity, blurred vision, and seeing floaters. The provider turns to Watson, linked through a tablet, and communicates in natural language the clues, the signs, and symptoms. Watson then accesses simultaneously a comprehensive set of sources such as textbooks, reference materials, PubMed journal abstracts and articles, and even blogs. Watson's natural language processing capabilities allow it to map to relevant medical concepts. The output shows two likely diagnoses, uveitis and conjunctivitis, Watson's value here is providing confidence in various possibilities, thus directing the provider to seek confirmation of the most likely diagnosis, uveitis, through direct examination. The next step is to provide Watson with other information about the patient that would make one cause more likely than another. Using the additional information, Watson generates a differential diagnosis for uveitis, where Lyme disease is on top, followed by many conditions with far less confidence. Watson also extracts critical information from the medical record that impacts on therapeutic choices. The patient is pregnant, and Watson is quickly able to find allergy to penicillin within the electronic medical record. The new conditionals change the profile considerably. At this point, Watson can provide suggestions for appropriate antibiotic therapy. Watson is much more than a search engine. Watson will be able to bring up-to-date information that will inform our diagnostic activities, will inform our therapeutic plans, and will enable us to practice literally state-of-the-art medicine on any given date.
Okay, so as we can see from the video, there's a lot of really interesting way that we can use unstructured information, and in this case to assist in diagnostic analysis. Here is a quick example of how that could work. We see in here various diseases, symptoms, medications, modifiers from sentence structure. As we begin to figure out what's going on in a given situation, we're going to look at all this unstructured information. And as the text is being analyzed and applied, where we're looking at symptoms, including the non-symptoms, looking at family history, looking at patient history, you can see on the right that the confidence of the diagnosis changes and improves as new information comes to light, looking at medications and then ultimately findings from test results. It's a very powerful capability. But that capability is already in use today. Watson leverages technology from our IBM content management solutions. It leverages a number of these core technologies, one in particular called IBM Content Analytics. This is a technology that's used today in the market in a number of industries, everything for call centers to understand what customers want before they ask, in insurance and financial fraud scenarios to detect fraudulent behavior and claims before they're paid out, in law enforcement and safety, public safety and terrorism, to dynamically deploy resources by understanding, natural language conversations. And then, of course, in areas like product quality to identify critical safety defects that can save costs or, in some cases, even lives. The technology, IBM Content Analytics, works very similar to the way Watson works, where we take these large amounts of text-based information, but instead of putting it into a knowledge store where we can ask questions, we run additional algorithms over them so we can do things like identify trends and patterns and correlations, find those connections, that context that is not easily found manually, to be sure. And then we visualize that information, or we can search it and explore it. And ultimately build out solutions that matter in industries like healthcare. Content analytics is a very powerful application in the area of healthcare. You can see kind of in the upper left here how a core look at unstructured information that perhaps is being pulled from an electronic medical record or other text-based sources of information. We can take that, analyze it, disambiguate it, understand the relationships in that text, and then, as you see on the bottom right, visualize it in a way that's easy to explore, easy to find things that we may not even have thought of. This is sort of the model of show me what I don't know or tell me what I don't know, as opposed to searching, which presumes you know what question you want to ask in the first place. So this technology applies in a lot of areas, certainly in healthcare. This is a great example of a customer using this today. BJC Healthcare and Washington University have a partnership, and they're currently now researching over 50 million records, unstructured records that are buried in clinical notes, nurses' notes, diagnostic reports. Now, previously, their analytics capabilities were limited to structured information, and they were using that. But by adding the unstructured information, they've really unlocked a new class of research that they're able to do. So by example, what used to take them months to go through, manually read these reports and try and figure out what was going on, they can now do in hours or even days. And by able to finding things significantly faster, which not only leads to lower costs, but in the case of this customer, they see this as competitive advantage for their role in the marketplace, including doing things like getting grants. They really see this as a game changer. IBM ECM and the solutions we have is not limited to just content analytics. There are a number of solution areas that content management can help in healthcare today, certainly imaging and capture, social content management, advanced case management, content analytics, which we've covered here, and information lifecycle governance. So with that, I'm going to wrap up my section of the presentation today. You can find me online at my blog or my Twitter ID, and I appreciate your attention in today's webinar and hope to catch up with you online.
Thank you for that, Craig, for that very insightful presentation. Just a quick reminder to our delegates today, if you've got any follow-up questions to put to Craig, you can either submit them in the questions section now, or indeed wait to put them to him directly at the end. Now, moving on to our next speaker, I'd like to introduce you to Andy Thomas. Andy is the Chief Information Officer at the Basingstoke and North Hampshire NHS Foundation Trust. So whilst I'm just handing over to Andy, if you could give us a couple of moments and we'll get started soon. Thank you.
Okay, first of all, welcome to everyone. My name is Andy Thomas. I'm the CIO for the Basingstoke Foundation Trust. I've been brought along today mainly to talk about how we use IBM throughout the trust, why we considered buying it, and how we're going to use it to deploy our vision of IT going forward. So I won't go through all the slides within the presentation. I'll try and keep it as succinct as possible and just give you the highlights of where we're going and what we're doing. First of all, I think we've given it the tagline of saying improving patient outcomes through functional efficiency. And we're trying to get towards this concept of straight-through processing. I'm sure, as all of you are aware, if you work within the NHS and Foundation Trust yourself, there's an awful lot of manual inputs when we come to pulling data through the trust out the other side. And one of the things we're trying to improve on this one is look for key points along those process lines to see where we can automate and bring that through so we get a cleaner process. So I'll move on to the first slide and say, well, we've got generic outcomes. We've all got generic challenges, across all the NHS trusts. We're all aiming towards a single EPI, which is a single portal. We want it to be available on all devices. We've been driven to reduce costs whilst not impacting patient outcomes and safety. We're certainly trying to reduce our dependency on the legacy clinical 5 applications. We're trying to provide a platform and infrastructure that can react to change and take control of that change. I think the one thing, I've only been within the NHS myself for the last 6 months. I've come from the investment banking field. And the one thing I've noticed since I've been in this industry is there is a lot of change coming towards us, and in some of those, there's a lot of uncertainty around that change and what it's going to be. So having a really strong platform and infrastructure behind us that enables us to react to that change, I think, is key. And we've taken the approach of having a service-oriented architecture. But rather than pinning all our hopes on one PAS system, if you like, one patient administration system, and building our EPR from that, we're looking at a best-of-breed approach and saying, okay, we'll take the best of what's available out there across our clinical 5, whether that's order comms or e-prescribing or the PAS systems. And we'll knit those together into a single view for the clinicians, both doctors, consultants, and nurses. And so we've taken that approach. It gives us far more control, I think, over what we're trying to achieve, and we can build specializations into our infrastructure. We're also taking control of our paper records through EDM. So we purchased the FileNet PH system from IBM, which is enabling us to sort of try and cut down on the amount of paper that's coming through the hospital and take control of that and actually have some view around it. We have endless amounts of piles of paper there, but actually it's very, very difficult to access. So what FileNet's giving us is that ability to index that information and have it easily searchable, and have it as a view within our portal. So again, that will be available within the portal. And one of the other things we're going to look at is saying, well, doctors, nurses, and clinicians in general tend to write things down. They'll either type it in free text, they'll write it down freehand, they'll use different ways of getting information in. And there's a lot of unstructured data out there that actually, if we were smart, we could convert into being very structured data. So taking that information and being able to use it. So if I look at and think about progress notes on a ward, I think it's very key that we should be able to get to that information and be able to use it and analyze it. At the moment, it's lost. It's good information, it's out there and it's controlled and we've got a process around it, but it is lost in terms of us being able to analyze that information. And I think, as you'll have heard before, using these new technologies, natural language processing, should help us to enable us to do that. What we've done is we've taken the hospital and looked at it and said, what are the key functions that we do as part of a patient journey? And no matter what you come in to have as a patient, whether you come in because you've got an ingrown toenail or whether you come in for something far more serious like cancer, we all go through the same effective processes and so functions through your life cycle. You're going to be referred, you're going to be assessed, you're going to be investigated, you'll be scheduled for some treatments, you'll get a drug even if it's just an aspirin or something. There'll be some form of intervention where somebody does some work on you, you'll be evaluated and you'll be discharged, and there'll be some form of follow-up and communication to you. So no matter what you do, that's going to be your journey. Some will be simple, some will be very complex. We tried to take these concepts and look and see what we need to build and what systems we need to build through that. I won't go through the detail of the descriptions of each of those different functions, but it gives you an idea of what we're talking about. When I talk about straight-through processing, what do I really mean? Well, really what we're talking about is capturing data at point of care, not capturing data retrospectively. Now, I can't speak for every single trust, but I know the experience we have within this trust at the moment, say for the e-discharge summary. Whilst we have an e-discharge summary, it's certainly not without the need for manual intervention. I look at the informatics team and they constantly have to refer back to paper notes to get a proper, fully fledged discharge summary out to the patients and the GPs. So we're trying to look at that and look at why we're not capturing data at point of care. Why is it that the clinicians aren't able to enter that data, and why we can't get that? Why we can't start enriching the discharge summary, almost from the starting point. We've automated a certain amount of it, so we can obviously get patient demographics, we can get which consultant they're under, we can get their take-home drugs, we can get those things automatically from the systems using the IBM portal. But it's the missing bits in there about the information around other aspects like investigations, what's actually gone on, and some of the written notes that go into the discharge summary. And we're looking to find out what those bits of process are and see whether we can provide tools that clinicians want to use. And our starting point with that is going to be the medical handover notes, the ward handover notes, which we're now fully automating. And we're going to be bringing that inside of the portal. And one of the things we've learned, and one of the things I've noticed since we've been here, is that we want to stop the tail wagging the dog, i.e. the corporate side of back office people trying to develop systems that they impose on the clinicians rather than developing systems that the clinicians actually want to use. We should be really looking at developing systems that add clinical value at point of care with a byproduct of good corporate value data that can be used for clinical research or can be used for more corporate activities and commercial activities. So rather than us trying to develop systems for the corporate requirements, develop systems for the clinical requirements, because that way you'll get buy-in. I think one of the limitations I've seen, again, as a new person to the NHS, is that IT in itself isn't that well embedded within the culture of the NHS, and that needs to change. And people are quite wary and quite nervous of using IT within the NHS, and we've got to change that, provide them with tools that they really want to use. So data capture tools need to provide a clinical value, and they're very easy to use. All data has to be managed and collected electronically, and all the data is enriched along that patient's journey pathway I just talked about before. And within that, you know, the coding that everyone talks about, the OCD-10, HRG, etc., is mapped automatically. So we're going to try and move to automating that mapping. And I know I've been told on a number of occasions that's an almost impossible task, but I don't believe it. I don't believe that's so. My experience of coming through these kind of processes before tells me that it's hard, without a shadow of a doubt, but it is possible. And we also want to work towards standards, common standards, using sort of the HL7 protocols. I know, not to oversell IBM, but they're coming out with stuff like it's called HICS, which is the Health Information Exchange, which will help us share information across trusts and out, not just trust to trust, but with GPs and, you know, ultimately with patients. And another thing with the straight-through processing is that all routing, all data routing, would be managed electronically with no manual intervention. So I think really what we're saying is we look at the e-discharge summary as an example. At the moment within the trust, it's very much a process. So at the end of a patient's episode or spell within a hospital, somebody will create an e-discharge summary. Some information is automated, but a lot of information requires the informatics teams, your information data teams, to go into the medical records and the paper records and get that information out and produce an e-discharge summary. What we're working towards, hopefully using natural language processing and using the IBM WebSphere tools and all the other tools that we purchased, the infrastructure that we've got, is to stop that being a process and just make that a report. So by enriching data along the pathway, the e-discharge summary should just come out of that. There shouldn't be any need for any manual intervention. Yes, you'll need a check. There'll certainly be a checkpoint before it goes out, but it should be automatically produced. Natural language processing, I won't go through this slide because, I mean, effectively, I think you've probably been through this before. Someone would have talked about what natural language processing is. But again, I think the main pro around this is, again, this move towards providing the clinicians with tools that they want to use. So they can, if they want to write things down, and we can, on bits of paper, that's fine. We can take that information and we can use, you know, optical character recognitions for stuff like that. We can use these new electronic pens that are out there. They could use new tools like the iPad to do their input. They could type it in. We're really trying to say, we're not going to worry too much about the input methodology because there are so many different ways in which people work. We need to develop tools where we can capture this data and use the natural language processing from them. So what are the pros? Mainly, clinicians can work now by entering plain text as they do currently. And the information with the medical notes, the discharge summaries, and the progress notes, and the handover notes, etc., will be made available for clinical research, which in turn will improve patient outcomes. So all that lost information that goes into the progress notes, it's going to be there, it's going to be researchable. And ultimately, clinical coding is then going to be simplified and automated through stronger data mapping. I think the skill set will be, as changes happen in HRG-10 codes, or sorry, HRG or ICD-10 codes, that those changes can be managed in a more structured fashion. We'll be able to take control of that. The cons of natural language processing, as I see them, because it's unstructured, the nature of the capture of the data is unstructured, it's difficult to guarantee quality. So the checking mechanisms and auditing around that are going to have to be strengthened. We're going to have to have tighter processes. I'm assuming that within the NLP world that we can put quality scores against the notes as we put them in there. So some of that we can take care of, but there is a risk around that. And also I think the other con is there's going to be a huge amount of upfront effort to teach the systems about the content that we're entering into there. But that's about pattern recognition and fine-tuning it. And, you know, we're aware that that's going to be a harder uphill struggle. So from an IT perspective, you know, we've put together a high-level vision and strategy of where we are now and saying, okay, we need to define clinical functions as we've got them, look at our overall landscape within IT, and then look to start building blocks of change over I'm guessing around about a 5-year period, which moves us towards the vision, which is having, you know, straight-through processing, and tools like natural language processing to help us along the way. Again, I won't go through all these blocks, but this is the kind of way in which I visualize it. If you start from the bottom, where at the moment we're going through the buy, sell, hold definition of our applications, and we'll move up through there, putting blocks of work in place, which gets us to the ultimate goal. Then finally, if I show you what our high-level architecture is, so you can get an idea of where we are and where we're going. We've bought the IBM WebSphere tool, which enables us to knit together the Clinical 5 applications you can see, or Clinical 4 down there, as you can see at the bottom, our PACS and RIS, our JAC, re-prescribing. We use Anglia ICE for order comms, and we personally use iSoft as our PAS. And as we merge with Winchester, we'll also have Cerner will come into play as well, because they're using the national program. And we're knitting those together using web services to produce a portal, which is an EPR, and a series of clinical tools which help the clinicians on their day-to-day. So they get a single view of everything they do within one portal. The data that comes out of these systems is also going to be fed into our, well, actually is being fed into our data warehouse. And again, we're using the IBM solution for that. That will then give us what they call a single vision of the truth around all our data. As you're aware, data quality is an issue within most trusts, and the data warehouse using ETL methodologies will seek to help us cleanse that data and understand where our weak points are so we can fix those upstream and downstream. We're using the electronic data management system, the IBM FileNet P8, to manage all our electronic data records, and we're rolling that out gradually at the moment through the trust. We're starting with gynecology, and we'll go through ward by ward and speciality by speciality until we've nailed all those things down. And ultimately, we're going to be looking at building an HL7 messaging engine, which I think is the HICS platform that I was talking about, the Health Information Exchange, which enables us to deal with any kind of message type coming in and out of the trust, so we can exchange information with our GPs, patients. The HHR you'll see on there is called the Hampshire Health Record, which is a central unit within Hampshire. We can deal with the PCTs, we can send out our referrals. Basically dealing with any information that we need to send out or receive externally will come through one unit. I'm not going to go through the other slides. It was really an example of how the e-discharge summary as an example of what straight-through processing is and why we're choosing that as our example. So I will end my presentation here. Hope it gives you some idea of what we're doing within Basingstoke. There's a lot to get through in a short period of time. And if anyone does want to contact me, please feel free. So I'll end there. Thank you very much.
Thank you, Andy, for that presentation, which I'm sure has got a lot of people in our audience today thinking. Once again, if you have any follow-up questions to put to Andy, you can either submit them in the question section now, or we'll obviously try and put them directly to him at the end. The final speaker for today's presentations will be Sunny Patel. Sunny is the ECM brand specialist for healthcare at IBM. So I'll just hand over to Sunny now, and we'll begin shortly. Thank you.
Hi, thank you for joining the webinar today. My name is Sunny Patel. I'm the IBM ECM brand specialist looking after the healthcare organizations. Today, as you've heard, we presented on your healthcare prescription for smarter patient outcomes, and I'm sure it's given you lots of food for thought. I'd like to wrap up the webinar today by giving you a summary of IBM's smarter healthcare capabilities, really giving you an overview with regards to the different types of solution offerings we have, and to discuss the pathway to becoming a smarter healthcare organization. Most of the challenges that we've heard today resonate around all NHS trusts, so typically around improving patient outcomes, increase operational performance, and to reduce clinical risks. These are the key challenges currently faced by most NHS trusts and also private healthcare. So within IBM's healthcare solution overview, if you imagine most trusts have multiple databases with regards to information around patients. You have paper medical records. So all this information typically needs to be shared across different clinicians. IBM's capability is to actually bring it all together. Bring it all together into a healthcare integration engine, and also bring together the paper records by providing scanning software to convert the paper medical records to an electronic image, and also then enabling certain information to be extracted from the actual document to aid metadata stored associated to the document, and hence improve your e-discovery of the actual information itself. One of the other areas in terms of people looking at is around clinical e-forms capabilities. So typically where you have some paper form process to try and actually look and see if e-forms is a way of reducing the amount of paper that you have and the logistics around that. So e-forms is a great capability around converting paper forms to electronic forms. IBM has a solution around care pathway optimization. Today we talked heavily around the healthcare analytics capability, and we also have something known as Initiate Master Patient Index. So my name is Sunny Patel, Sandeep Patel, S. Patel. I'm the same person. You may have my name stored in multiple systems, slightly misspelled with regards to my name. My NHS number and my address is the same. So we have a tool that can help you actually put that all together. Health information exchange is something that we're heavily involved in. So with regards to the way industries are working at the moment, we're working with NHS trusts and local authorities, GP commissionings. Information needs to be shared between many different organizations. And it's important to try and have a standard, and that's something that we're working on with the health information exchange. If you imagine you've got all this information on your systems, you need to then provide it to be seen by clinicians. So IBM Healthcare Portal enables you to actually provide community workers as well as clinicians within the hospital environment to see all this information on effectively as a 360-degree view. So these are the capabilities instead in terms of what IBM has. I appreciate that many organizations have already invested heavily in certain parts of the solution option that we're talking around here. So our approach is really not a rip and replace. We truly believe you need to make the most of certain solutions that you've already actually purchased. So there's elements of this offering, if you imagine, that may be of relevance to yourself. So we wouldn't expect you to get there with everything, but obviously you would want to actually make the best of some solutions that you already have and have add-on approach, adding certain modules or adding certain parts of our capabilities. One area typically is around medical records. So most organizations are still working with paper medical records, and typically that's an area that I'll talk a little bit about. So in terms of the pathway for smarter healthcare, what we typically see here is a graph that shows IT optimization is the key. And typically, if you imagine maturity over time against clinical care value, electronic medical records is an area where you could actually reap some benefits. So typically, what we're looking around is converting the paper records to electronic format and then enabling that to be shared. We talked also about healthcare portals to share this information, health information exchange, and health analytics. And a key area as well, which is advanced clinical decision support, is something that's a hot topic within the IBM and healthcare organizations. So I consider enterprise content management for patient records. The answer is pretty straightforward. It's to help you improve patient outcomes, to give greater accessibility to patient records, give a single view of the patient's records, and the ability to share this internally and externally. One of the other benefits, obviously, is around cost saving, so storage space, saving around costs on that, eliminating logistical costs as well. So, paperless office, is it a reality? Well, most organizations probably don't think it's going to actually happen. You'll become paper light, but probably never paperless. And typically, there's the main reasons as what we just mentioned. So, converting paper documents itself to electronic formats, you need to be able to scan these documents and convert them into an electronic format. And scanning solutions, if you like, we have the capability of providing a basic capture system, which would do optical character recognition, barcode recognition, and we see that as a basic functionality. One of our other capabilities is to provide a department capture system, which enables you to actually extract line item details from, for example, an invoice which has multiple line items, and actually make sure that the totals calculate correctly. We have optical mark recognition and intelligent character recognition as well within the departmental capture systems. The area of focus really for NHS trusts, I believe, would be enterprise capture type of solution. So it includes everything that I just mentioned, but also advanced document classification. So ingestion of information that you already hold into a central repository, utilizing some of the natural language capabilities that we talked about today. And also web services. So typically when you imagine you have multiple sites that need to scan in documents, you could actually do them via the web service. So DataCap Taskmaster is actually our solution offering with regards to scanning and capturing information. And one of the main things I just want to point out here is regarding the way it's actually priced. So many scanning solutions are charged normally by clicks. So per page you have a cost associated. So as the volume increases, your charge increases. With DataCap, IBM DataCap, we actually charge you per a license-based model. So we're not worried about the volume you're putting through, it's based on a license. So therefore, you could actually save a lot of money with regards to looking at scanning solutions like DataCap compared to paying per click. And we've had many cases where people have actually invested in a pay-per-click type of scenario and now swapped over to DataCap because the actual overall cost and setup is a lot less due to it being on a license-based module. And the way it works is very intelligent, so it's very simple and easy to set up. So intelligent data extraction is one of the keys in terms of the solution. And the strongest drivers for scanning and capture is to improve searchability and knowledge sharing across the business, followed by productivity improvement, and reduce office cost and better customer service, which is obviously key. So today we talked a little bit about Watson, and as a summary, Watson was effectively the solution that we made to help effectively beat the best two players in the world for a game show called Jeopardy. And the power behind it, one of the powers was the natural language processing capabilities. So today, really, what I wanted to just finalize and tell you about the Watson part was this type of solution offering and understanding text, understanding context, semantics. You can extract symptoms, findings, personal history information from, for example, a medical case note. Normally, you would need somebody to actually sit there, read this, and actually code this information and convert the unstructured data to structured. We have the tools to actually help you do that a lot quicker. This solution can also be used, if you like, for classification of documents, so advanced classification. Normally, classification of documents is done by a knowledge worker, has a look at the information, and manually actually classifies the document itself. It's not cost effective, so it costs a lot of money, and effectively your accuracy levels are fairly low. If you use rule-based classification, so for example, maybe you've got some sort of barcode on a form, you could scan that, and it could automatically understand that it's a particular type of form. That would be a lot quicker, and we have that capability. And the area that we're really talking about now is advanced classification using context-based classification. So using the capabilities of understanding natural language, extracting information from paper documents and classifying them using context-based classification as well as rule-based. So multiple methods giving you high accuracy and great productivity and cost savings for ingestion of documents into a document management system like Pharma, for example, which is one of our other solution offerings in document management and enterprise content management. One other area where this type of solution offering could be used is if you imagine you have somebody who leaves the organization, you have a load of emails, you want to try and actually know which emails do you want to keep, which emails do you get rid of. The solution can actually identify which are personal emails and which are business-related emails. So enabling you to clean up your organization. And email is just one example, and I'm sure you can appreciate there's many systems here that you have where you have critical information that could be utilized to clean your organization's content. So as a wrap-up, just want to give you the last presentation slide, really giving you an idea of business solution entry points that IBM Enterprise Content Management has. And today I touched a little bit around document imaging and capture, so scanning and collecting your paper documentation into a central repository. We have social management applications which enable us to obviously bring in native Excel Word documents into our solutions and help you share this. Advanced case management, if you imagine a patient starting their journey, so the first time they start an episode within a hospital trust, it's up to a knowledge worker to determine the pathway that you take for better health. And typically that knowledge worker would determine the business process. It's complex, it's content-centric. Advanced case management gives you the ability to deal with complex routing of a case. And also gives you some case analytics. So if, for example, you had some bottlenecks with regards to long queues at X-ray departments, it could identify these types of things for you within a process. So a very good tool for monitoring. Content analytics is something we've heavily spoke about today. It's the buzz stuff at the moment because it's brand new in terms of natural language processing capabilities and also looking at predictive analytics with that. So there's some stuff happening soon where you will actually see some new solutions coming out together utilizing this type of offering. Information lifecycle governance, so typically looking around records management and lifecycle of documentations, email alerts at the end of a lifecycle for storage of some information, electronic discovery around your enterprise, we have some capabilities around there. Advanced classification is something I also talked to you about today, utilizing the natural language processing ability to ingest information into a content repository like Pharma. And finally, we talked around bringing in all other content within your organization into a central place. So I'd like to just wrap up today and say thank you all for your time. My contact details are now on screen. Please do contact me if you have any questions, and I'd look forward to speaking to you soon. So once again, I hope you found the actual presentation interesting, and I look forward to speaking to you when you have a chance to contact me. Many thanks for your time.
Thank you, Sonny, and thank you very much to all of today's panelists for those presentations. Now is the time for today's Q&A. Unfortunately, by the looks of it, I think Andy has either lost his connection or has had to dash, but we've lost Andy for the time being. I do know we've had a couple of questions posted in for Andy, so what we will do is ensure that if he can't join us in the Q&A over the next few moments, then we'll email those questions across to him, and no doubt he can respond accordingly. Anyone with any questions at this point, you can either write those in into the question box, or indeed type me or raise your hand as part of the facility there, and we'll come to you directly and you can pose your questions to any of the panelists. But I do know actually Craig and Sonny. We've had a couple of comments in here. First of all, I was interested whether you'd be able to explain anything around the announcement made last week at the Information on Demand conference. Craig or Sonny, if you potentially want to mention anything around that?
Yeah, I'm happy to. This is Craig. Sonny alluded to it in his presentation. I didn't cover it in mine, but basically we made an announcement last week at IOD, which is a customer conference in Las Vegas. About 11,000 customers globally come to that. And we announced our first Watson-ready solution, something called IBM Content and Predictive Analytics for Healthcare. It leverages the same IBM Content Analytics that was talked about earlier during my session, and what we've basically done is integrated that into a solution for healthcare with specific medical terminology, the ability to extract medications, diseases, symptoms, non-symptoms. Many of the things that you saw in the example now come sort of bundled in an out-of-the-box solution that can be easily customized for specific applications. So it was pretty breakthrough announcement. It's the first real solution that customers can buy today that is on the path towards Watson, and there's already customers using this. We've been working with a few early customers in this area. Were there other questions on the same topic, or was there something that you wanted me to go into more detail on that?
Well, Craig, there's a comment here that's popped in saying, what problems does IBM Content and Predictive Analytics help with? If you want to touch on that at all, Sonny?
It's really at the intersection of clinical and operational decision making. There are a number of clinical areas such as critical care intervention, treatment effectiveness, research for improved disease management, diagnostic assistance, and so forth that really need these insights from unstructured information to be unlocked. If you think about all the data, more than 80% is unstructured. Right? In healthcare, this is particularly a daunting challenge with all the terminology that's unique to the industry. So unlocking those insights and then using that information to drive better outcomes, better patient care, eliminating unnecessary cost from treatments, helping to prevent readmissions. It's a known problem, as an example, that many readmissions are preventable. In the U.S., that statistic is 20% of the readmissions. Patients leave the hospital, they're discharged, but they come back within 30 days. That 20% of those are preventable. It's a global problem. I don't know what the statistic is globally, but it's a sizable number. The point being, to your question, or the question of the questioner, is this new solution can unlock the kind of information that will allow organizations to take action and intervene and stop those cases where coordinated care can help with readmissions. In fact, the first customer that was announced with the new solution is Seton Family Healthcare, and that's exactly what they're doing. Is they're looking at congestive heart failure, and they're looking to identify those patients where intervention will make a difference in care and take the necessary steps to intervene. And it all starts with understanding what are the trends and patterns in information that show you the reasons or the factors that these readmissions are happening, and then evaluating that against the current patient population so you can figure out, based on the current population, which patients need care and go take the necessary steps to impact that care. So it's a pretty compelling use case. I mean, any time that you can use information to deliver that kind of an outcome to improve patient care, nobody likes going to the hospital. So that's from my view, very compelling way to use content management.
Well, thank you for that, Craig. We do have another question here saying, is the analytic engine available as a separate tool, as we already have a document management system?
Yes, content analytics will work with any repository. It can also handle structured data. So it's not just IBM repositories. It can be, our competitors' repositories or file shares, SharePoint, Documentum, OpenText. You name it. There are. It can work with that. So it is not tied to or dependent on other IBM technologies.
Well, we do have a hand raised. I don't know if you're still on the call, Sue, but if I come to you, if you want, once you hear unmuted, if you'd like to introduce yourself, your organisation, and then put your question forward. Sue, if you just bear with me 1 second, I'll just do that for you now. Oh, in fact, I think Sue may have left us actually. So. Perhaps you've already covered that question in the previous answers. I don't know if there are any further questions at this time, or any other comments, either Craig or Sonny, you'd like to add at this point?
Mark, yes. If I could just make one comment, if that's possible, whilst you're waiting to see if anyone else has any more questions. So one of the key areas in terms of that I've been engaging with some hospitals is around e-discharge summaries, which you've mentioned with Andy's presentation today, but also around pathology reports, X-ray reports, and really trying to get some meaningful insight from all this information that's held unstructured with regards to the tech. So what I would love is for an organization to come up to me, or to introduce themselves to myself, to tell me of the problems that they have around unstructured data, and to really show you what our capabilities are. Recently we had a few people down from certain hospitals to actually our innovation site, laboratories in Hursley, and they managed to bring some data sets around X-ray reports, and really found some real interest within an hour of just putting the tool to the data sets. So it's great actually hearing about the presentation and understanding what we can do, but actually seeing it in practice is something else. So certainly, you've got my contact details on screen. Please do contact me if you'd like to take me up on that. Thanks, Mark.
Yeah, and just to build on that, this is Craig again. Just to build on that, I mean, ECM helps in a lot of different areas in healthcare. I mean, even the basics like converting off of paper records using technologies like DataCap to extract the information from paper records, so those documents can be properly managed over their life cycle, and that information can then ultimately be analyzed and injected into processes, made part of cases, and so forth. So there's lots of ways to, regardless of where your particular maturity is on the use of ECM technology in healthcare, there's lots of different solution areas to think about to get value from.
Well, thank you very much for that, gentlemen. Just concluding today's webinar, if I can thank everyone for attending. You will all receive an email tomorrow which will contain a link to the recording. With that, there will also be a PDF download. So I do know that one or two have mentioned today whether they could access the notes to this presentation. We'll ensure that we share that with you, and indeed that will allow you to share with colleagues. So thank you very much again for attending. We look forward to having an opportunity of speaking with you again very soon, and good afternoon.